Well, good day everyone. Today we're going to be looking at the parts of a circle. Alright, so here's the, oh dear, that didn't go well, did it? Let's go back. Tell you what, let's rub that out. Okay, we're going to be looking at the parts of a circle, so that's the word circle. And as we've seen over the last few days, the circle has a center, it has a point, it has a radius, and it has a diameter. And the diameter is 2 times the radius. That's really important. So the diameter, we can say, is 2r. Right, and then the other things we need to know about a circle are its circumference. So the circumference of a circle is the distance all the way around it, and it's given by this formula. No, it's not. It's given by this formula, pi times d. And remember, pi is just a ratio that works with circles. It's just a number. And I think you know it's 3.14. Okay, and the other important thing about circles is how to measure the area. Now, the area of a circle is a little more difficult, but the area is given by the formula pi r squared. And that means that you square the radius, which is that little half measure across the circle. You square that measure, so if the radius is 3, you'd square it and you'd get 9. And then you multiply that by pi. And that gives you the area. So that would be 9 times 3.14. And that would give you the area of the circle. And it would be expressed in square centimeters. Please don't forget. Right, in this little problem, we have a running track. And we need to know how long the running track is. It says find the length of the running track. So, if you're running around here, you want to know how long it is, right? It says that the running track is made up of a rectangle. I'm going to write a big R in the middle there. And then 2 semicircles. So there's a semicircle here at the end and another semicircle here at the end. Now what's important to realize is that you need to break this little diagram down a little bit. We have some measures for the sizes of these shapes, but you need to break them down. And the best way to break them down is to take the shapes and actually show that what we've got here is in fact a circle plus a rectangle. And we know in this case that the size of the rectangle from the original diagram is 100 meters by 64 meters. So for this running track we need the perimeter of the rectangle. Actually, we don't. We need the 2 top measures, the long measures of the rectangle. So we've got 100 meters there and 100 meters there. And if we want to find the size of our running track, that means we've got that length and that length. Now, down below we have our semicircles joined together to make a circle. Right, so what we then need to do is find out the circumference of this circle, because if we find its circumference, we will have that measure there and that measure there, and that will help us find the size of the running track. So this 64 is clearly the diameter, because it's a line that goes across the shape. So D equals 64 meters in this case, and therefore pi d, or the circumference, will be pi times d, and pi times d, which is 3.14 times 64, which is equal to 200.96 meters. Now I think we'd probably go with 200 meters, because we now have, for the size of the running track, we have 100. We have 100. And then we have 200. So essentially this is 100 because it's split into two, and this is 100. So this, my friends, is a 400 meter running track. And that is your answer.